Next, we will explore the best practices for creating Docker images and running Docker containers. Learning Docker is not enough. Learning how to master it is the right way. Creating and managing Docker containers is the real challenge is making them efficient, scalable, and secure is where the real magic happens. Okay. So now we will see why the best practices matters. Have you ever about this issue? It works on my machine. Let's say you developed a mobile app that is working on your mobile phone. The same mobile application, when you share it with your friend, it is not working. Or you take any application, it is working on your laptop, it is not working on your friend's laptop because of the environmental issues, version issues. And the next issue is right. It takes longer time to build your Docker image. It is slow and bloated containers, right? And the other key issue is what if your containers are vulnerable to attacks? The other topmost concern is right. Are your deployments consuming unnecessary memory and CPUs? Following best practices will make our containers lightweight, faster, and secure. Okay. So for that reason, understanding the best practices or learning the best practices, very much important. The first best practice is use a minimal base image. Instead of using Python 3.9, use Python 3.9 Slim. What is Slim? Here, the Slim will tell your Docker to use only the base packages are related to your Python 3.9 instead of installing all the packages that are related to the Python. You just use only the base image of your Python so that it will save space, right? The image size will be smaller. It will not be too big. The next one is reduce layers in Dockerfile. What do you mean by reducing the layers? How many of you are familiar with Docker layers? What are layers in Docker, guys? Excellent. One good answer. Okay, very good. So Docker builds images in layers, right? And each instruction in your Docker file, like the from, run, copy, creates a new layer. So these layers stack on top of each other to form the final image. Okay. So the layers are cached, which speeds up builds if the earlier layers has not changed. Okay. And the next thing is right. Why do we need to reduce layers? Every layer it increases the image size and it slows down the builds. Okay. Hence, reducing the layers makes your images smaller and efficient. Okay. So the classic example is, for example, you have written something like right run apt get update, and then the next line run apt get install minus y curl, and then the next line you write run pip install minus r requirements.txt, right? Instead of that, instead of writing each command separately, wherever it is applicable, you can use multi-command layering. You can use run, so apt-get update double ampersand, and then you backward slash backslash, then apt-get install minus y curl double ampersand, and the for backward slash, and then pip install minus or requirements.txt. So in this case, it combines multiple run commands into one layer. It reduces your image size. This is one of the best practices. I don't know how many of you followed this one. Okay, this is in fact I tested it, right. So it reduced my image size with multiple lines of commands and combining the multi-command, so into multiple commands into a single thing, right? It obviously reduced my image size. Okay. And the next question is, how do I check layers in a Docker image? What you do is, right, you can type Docker and then history and then your image ID. For example, I just go to the AWS console and here I just check your, one second, Docker. Yeah, here Docker works and then Docker history. Okay, before that, I want to see the images. Are there any images are there? Docker images. We can see this many number of images are there. What I do is, right, I just say Docker history, the image ID here. I just use something here. 3 days ago, we have created it and I just paste it here. Using this command, you can see the, okay, permission denied. Okay, okay, 1 second. I just, I use sudo docker history. We can see this one. So how many layers are there in my Docker file? Look here, I just show you my Docker file. This is my Docker file. It shows, this many number of layers, right? If you want to see all the layers that are part of your Docker file, which is nothing but your image, you can use Docker history, that image ID. How do I get the image ID? Docker space images. Okay, you need to prefix with sudo. But instead of using sudo, right, the best practice using the sudo every time. Best thing what you do, right, you can add the user to the Docker group. So now if I try the same thing, I don't need a Docker here. I just remove it, Docker. Okay, still it is causing problem, and we have this is another problem. What we will do is I will be do the change mode thing, right? I will just change the permissions for run docker.sock. Okay, and then I just give it a try now. Even then, we are getting this issue. So now I got it. What this uses? Can someone tell me? Simple, simple thing is, you can try restarting your Docker. Ideally, once you add your user to the Docker group, you can exit it and relog in. Okay, but you don't have to restart it. Exit and relog in. That I think that in that case it will work. Docker history. No, no, still that issue is there. Okay, yeah, I got it now. What I do is, right, I just make changes to the group. Okay, I just use new grp and Docker. So look here, new group Docker, and then when you give this one, right, Docker is working fine. Okay, so yes, 1 second. So what is the next best practice? Just now we have seen reducing the layers will be helpful in terms of reducing your image size. And also we discussed about what is a layer and what are the layers are there, right? How to check them. We have seen it. The next one is the efficient resource allocation. Okay. I just go back here. The next one is efficient resource. Limit CPU and memory. How do I limit the CPU and memory? So here, for example, when you run your Docker container, run -d, and here my port number is, yeah, instead of giving the port number, I just use the option called memory is equivalent to, I just say 512M and then hyphen CPU is equivalent to 1. And then I just say my app name, okay, Flask AVP or so, or Docker images. What are the images? Okay, Docker Flask keep. Yeah, Flask. Sorry, there is a typo here. Flask hyphen app. Correct only, right? Okay, what was that error? Hyphen CPU. Okay, that is where it is showing an error. CPUs here, not CPU, CPUs. Yes, you are correct. Manoj, you are correct, right? CPU is equal to 1. So now we could see that Docker run -d. Okay, this is what is working. So in this case, this container will consume 512 MB memory and only one CPU will be utilized by this one. Okay. Okay, so why do we need to do that? But it prevents the containers from consuming excessive system resources. Okay, but now the question is, how do I know if 512M is sufficient and one CPU is enough? That is a good question. But for that, you need to some kind of capacity planning, and you need to know the non-functional requirements, something like how many number of users are going to access your Flask application or Fast API application, which is running inside your Docker. So based on the number of users, you can determine the memory and the CPU requirements. And what is the next one? The use multi-stage builds. What do you mean by multi-stage builds? Okay, in that case, right, you can probably you can use the Docker Compose also in case you want to build a create more than one container, right? So you can use Docker Compose also. And other best practices, by default, Docker runs as root. Okay, so you need to add a user to improve security, right? So that is what we did it a while back. Okay, and then expose only necessary ports. For example, you want to expose the Flask port, which is 80,000, sorry, 8,000. Expose only that, and also the other important best practice: use environment variables for security. Do not ever hard code credentials in your Docker file. Okay, even if you do it, whether the hackers is going to attack or not, the AWS will block your account. Okay, don't ever do this one. Okay, this is so how do I do this one? For example, right? So Docker run, you can say something like and your DB password is the right. So DB underscore password. So this is a variable, okay, and is equivalent to I just say my secure password. Skype and app. Got it. So this is how you can you can prevent or hard code, preventing the hard coding the credentials in your Docker file. Okay. So now the question is, so what is this my secure password? Very good question. There are different techniques are there. For example, that in the case of Docker Swarm, you can create secret password. For that, you need to use a different technique. And even the case of Docker Compose, you can follow different techniques. Let's start with a simple example. For example, I'm going to create an .env file, and in this case, let's say, here I just say echo my db underscore password is equivalent to let's say, my password is Jack and Jill. I'm going to redirect it to a file called env. And next, what I do is I just say docker run and -env file space .env. That is the file that I created, right? And my app name is my image Flask app. My Docker image is this one. I just try this one. Yes, it's working fine, right? So the advantage is the password is not exposed in command history. It keeps environment variables organized. Okay, I just press Control C, and we will see the content of the env file. Yes, this is where the password show. So this is one of the techniques that you can use it for different type of Docker, like your Docker Compose and Docker Swarm. You need to use different techniques. Okay. And the next thing is we will see Docker Compose and Docker Swarm in the next session. So to summarize, right, we covered a lot today. So let's quickly recap what we learned. Keep the images once again. Keep the images lightweight. Use minimal base images. I mean, like the case of Python, right? So instead of Python 3.9, use Python 3.9 Slim, okay? And optimize your Docker file layers, arrange instruction for caching efficiency, and then enhance security, avoid running as root and all, okay? So, and what else? And also, right, we can enable logging and monitoring, implement structured logging and centralized monitoring. And last but not the least, This I did not discuss. So now you can automate everything, right? So you can integrate Docker into CI/CD pipeline. Following this best practice will definitely help you build faster, more secure, and more efficient containers. Okay. Thank you all for joining today's session. I hope you found this valuable and that you will apply this best practice in your project. So before we wrap up, do you guys have any final questions? If you would like to dive deeper, let's stay connected. Okay. All right, guys. With this, I'm going to wrap up this.